Hi folks, welcome to 5.2 video number 3. So in this part we're going to talk about properties of definite integrals. And here's all of the properties that we have for definite integrals. I just wanted to have them so that we had them in one place, but rather than read through them, what I'd like us to do is kind of apply them and see how to make sense of them, okay? And what these things are really asking us about. A lot of the times I do the properties of definite integral problems with diagrams because I find that it makes it more visual and less a whole bunch of symbols and I don't know what's going on, okay? So let's start with question 6. It says, suppose that we have these three integrals. So I'm going to say from negative 1 to 1 of f of x, and that equals 5. And then separately from 1 to 4, f of x is negative 2. And then third, I have from negative 1 to 1 for h of x is 7. And so let's see what this means. If I were to sketch a diagram for this, okay, then I would think that I could draw two different ones. One for the f of x one and one for the h of x. Now the h of x one I think is going to be pretty straightforward. I can just say that I have this function and from negative 1 to 1, that area is 7. Now, I don't really know what the function looks like, but I can at least draw an area. It could be a rectangle. Some people like lumps or circles, and that's fine too. Whatever your preference is fine. But let's see if we can do something similar for the f of x function. So for f of x, and let me maybe erase this part a little bit. The f of x function goes for longer than the h of x. So it starts at negative 1 and it goes to 1. And that part we could say is 5. And then from 1 to 4, we could say that that part is negative 2. Okay? So this part is 5. This part is negative 2, and this part here is 7. Okay, so let's use that to help us unpack these questions. Well, I know for the first question it says from 4 to 1. So I look at my diagram and I'm like, okay, 4 to 1, well, that would ask me to read my diagram backwards. And since it asked me to read my diagram backwards, I take the area that they give me and I change the sign. So negative 2 will give us an area of positive 2. So it's not necessarily that we're finding a new area, but we're looking at it from a different perspective. Okay, let's move on to part B. So part B says, let me get rid of that pink arrow. Part B says I want to start at negative 1 and I want to go all the way to 4. Well, that means that I'm starting here and including all of this. And so that would be the same as saying 5 plus negative 2, or the first area plus the second area, and I would get 3. Okay. So let's move on to part C. Part C says that we're going from negative 1 to 1 of 2 times f of x plus 3 times h of x. So this is a good one to think about this sum and difference identity. So I can split them up into multiple integrals and think about the area that corresponds to each integral. So I can write this as integral from negative 1 to 1 of 2 f of x dx plus the integral from negative 1 to 1 of 3 h of x dx. Now that is the same as saying 2 times the integral from negative 1 to 1 of f of x dx plus 3 times the integral of negative 1 to 1 of h of x dx. And now we just need to find our numbers. So this we saw earlier equaled 5. And this we saw earlier equaled 7. So this problem is really saying 2 times 5 plus 3 times 7, which equals 10 plus 21, or it equals 31. Okay. All right, let's move on to part D. So part D, if I look at the starting and ending points here, I start at 0 and I go to 1. Now, according to my diagram, if I just look at that part of it, negative 1 to 1, we drew it like this, and we said that that had an area of 5. So I could totally understand why some people would say, oh, well, this is 2.5, right? It's half of 5. That's a big fat no. And here's why. This is just a sketch to help us kind of understand what we're doing. But I could have just as easily drawn something like this, from negative 1 to 1, and it was like flat here, but then it jumped up and all of this area was 5. That's still the same thing. But that would make my answer for this question equal to 5, not 2.5. So there's a lot of different ways that I could draw the diagram that I can't just split it in half. So for this question, you could say that there's not enough information. Okay, there's not enough information. And that's going to happen sometimes. Sometimes you'll have information like A and B and C, and sometimes like D, you won't have enough. So it's really important that you know how to make that decision. All right, let's take a look at these last two here. So this one says h of x, which is the orange graph, but now I'm going from negative 2 to 2. Well, according to the information I have, I only know what's happening between negative 1 and 1. I have no idea what's happening here or no idea what's happening here. So this is another case of not enough information. Okay. All right, last one here. I'm starting at negative 1. And I'm going to positive 1 of f of x plus h of x. So this is really similar to question C. And I can split it. So I can say the integral of f of x dx from negative 1 to 1 plus the integral from negative 1 to 1 of h of x dx. And that will just give me 5 plus 7, which will give me a total of 12. Okay? So that is one example that you could do with properties of integrals. All right? So we did the interval addition. All right? The interval addition would be like question 6b. We did the backwards one, which is like 6a. We did the sum and difference, which is like 6c and e. And 6c also had the scalar multiplication. And now we haven't seen this one, but that's okay. It acts the same way, okay? If I take the whole graph and I move it sideways, I don't change the area underneath there. It just doesn't change, okay? It's only when I move it up and down that I would change the area. So let's go ahead and do one last example here, question number 7. And I left myself some space to draw the diagrams this time, okay? So let's go with this color coding situation again. I've got one area from 1 to 2 of f of x dx, and that's negative 4. I have another one from 1 to 5 of f of x, and that's equals 6. And I have one last one from 1 to 5 of g of x from 1 to 5, and that gives me 8. All right, so here is my f of x graph. My f of x graph, I know from 1 to 2 something is happening, and then from 1 to 5 something else is happening. Okay, so from 1 to 2 I have something below the axis, and that area is -4. And from 1 to 5 I have some area, and that area is a +6. Now, if I draw a similar sort of diagram for g of x, all right, so this will be our g of x one. I know from 1 to 5, I end up with an area of 8. Okay, so let's use those pictures to help us with these questions. So let's start with A. I want to go from 2 to 2 of g of x. Well, I only know what's happening from 1 to 5, but from 2 to 2, well, that would mean that I start here and I end there. That's just a line. If it's just a line, like the bottom bound equals the top bound, so A equals B, then what happens is that area is going to be 0. Okay? Now, I could have said the same thing, the integral from 7 to 7 of g of x dx, and even though I don't know what it looks like at 7, I know that area is going to be 0 because the top bound and the bottom bound are the same. Okay? All right, part B, I'm going from not 1 to 5, but I'm going from 5 to 1. So I'm going backwards. Backwards means same area, but change the sign. So we get -8. Okay. Ooh, looks like a constant multiple. So I'm going to take this 3 out for part C, the integral from 1 to 2 of f of x dx. Do I know the integral from 1 to 2? Sure do, that's that -4, so 3 times -4 will give me -12 for the area for part C. Okay, part D. Well, part D is asking us not from 1 to 5, but 2 to 5, okay? So we actually have kind of a subtraction problem here. Because what I could say is that the integral from 1 to 2 of f of x dx plus the integral from 2 to 5 of f of x dx will equal the integral from 1 to 5 of f of x dx. Now, I have this as -4, plus this is what I want to find, 2 to 5 of f of x dx, which equals 6. And so when I move that -4 to the other side, I will get an overall area of 10 from 2 to 5. Okay, let's see if we can answer question E. Question E asked for 2 to 5 of f of x. That we have, but you know what we don't have? We don't have g of x from 2 to 5. So this one is not enough information. All right, let's see if we have enough information for f. That is the same as for the integral from 1 to 5 of f of x dx. That's that blue one that we have from above, minus the integral from 1 to 5 of g of x dx, which is the orange one. Okay, so we've got 4 times 6 minus 8, or 24 minus 8 will give me an area of 16. All right, folks, that's it for part 3. Come on back for the last and final part, part 4. See you there.